Hey, welcome to a new episode of SDV Coffee Talk with the topic of cybersecurity in SDV today. Just a small disclaimer from my side. I mean, everything what I say is my own opinion and has nothing to do with my employer. I have for today my co-moderator, so to say, Florian, and two guests. Let's have a small introduction round and then we can probably start. Kati, you want to start?
Sure. Thanks, Fateh and Florian for having me here. I'm Kati. I'm from India, but hailing in from Stuttgart, Germany. I have close to 10 years of experience in the automotive safety and security. I started my work experience with Jaguar Land Rover as a functional safety engineer back in India on the battery management systems and the DAS level 2. Then I moved to Germany. I worked in DEKRA, which is a cybersecurity certification company. I worked for more than 3.5 years for the R155 and ISO 21434 standards and regulations. And right now, I'm supporting a couple of tier one companies based in Stuttgart, in and around Stuttgart, on their certification journey, and also closely working with Florian on the OTA, quantum safe OTA updates for the next generation software defined vehicles to make software defined vehicles more secure. Sure,
Thanks.
All right, so I believe it's my turn. My name is Abdurrahman Mabrouk. I'm an software architect in Intellius. I've been in Intellius for more than 4 years, and I have an overall experience in the automotive industry, almost 10 years of experience, starting from OTSAR software architecture, then switching to the functional safety. I'm a certified function safety engineer, certified cybersecurity engineer, and I'm focusing on the cybersecurity and the architecture and how we can mainly secure our architecture or the zone architecture that is the key player for the SDV. So I believe this is a crucial part that we need to talk about, and this is the main point that we are going to tackle during this talk. So I'm happy to be joining you guys in this talk.
Thanks, Mabruk. I mean, Florian, you want to say something about you?
I'll keep it short. I'm in the automotive industry for 20 years. I've been at Conti, Tesla, NIO, and currently as a process consulting, where I'm also working with Conti. I am doing a few projects around cybersecurity, but nothing to the ends of these two gentlemen. So I'm personally really excited for today's talk, and I'm sure I will learn a lot as well.
Cool, thanks. Then let's start with a simple question. Actually, I mean, nowadays, in context of SDV, cybersecurity is very popular. I mean, I joined to meetups where people were talking about cybersecurity in SDV context. And so, why this is now so important? Why this was not important in the past? Is there any, what changed? Why we talk so much about cybersecurity in automotive? Can't you probably you can.
One simple answer: connectivity. So nowadays, every vehicle is connected from chip level to the cloud level. So every connection is a new attack vector. So that's why we need to treat cybersecurity for the software-defined vehicles as a new DNA, which needs to integrate it from the design phase itself. So that's my view.
Okay.
Yep. Maybe adding to you, Kurti, that it's a shift from the product security into the life cycle security. You need to secure the full life cycle of the vehicle, starting from the supply chain, from every supplier, for every pit that is contributing to the vehicle itself. So starting from maybe the cloud or the server-based suppliers to the suppliers that are supplying maybe something simple as the bolts, for example, to just the mechanical parts. Because everything, as Karthi mentioned, this is an attack vector. This is a vulnerability. If one is trying to attack it or the hacker trying to attack it, it will just make the full chain vulnerable for the vehicle.
Yeah, so and one thing, sorry, go ahead.
Finish yeah, sure.
So one thing we are seeing now is that the vehicles are connected, yes, to the internet, but they're also connected to each other, right? So what we now can see or imagine is what you call swarm attacks, right? So you can actually find the lowest entry point, so the easiest entry point, the most vulnerable entry point, and you have to go, and then you can actually go and spread that out over a fleet or a region or something like that. And so the whole approach of SDVs with their connectivity and the V2X systems and ideas, as well as updatability, and I'm sure Katja has a very strong opinion about that, that actually opens a lot of new ways for cybersecurity attacks or for cyber threats.
Okay. I mean, I had a couple of discussions actually also with friends in automotive. There is this notion of okay, cybersecurity. Every security problem can become a safety problem in SDVs, and how to handle this actually. You know, I mean, if for example you have steer by wire or brake by wire or something like that, you don't have any mechanical stuff anymore. It's everything cable. And every security problem could be also a safety problem. What do you think about that? I mean,
so just a real quick thought. It's so much more amplified in SDVs, but it's not starting with SDVs. You can have safety issues caused by security problems also in EE architecture. There was a guy once, he actually hacked into a Toyota Prius radio, and through CAN error frames, he made the engine shut down on the freeway. So
really?
It's possible, right? But the spread or the spectrum of possible attacks is like an order of, or probably several orders of magnitude.
Actually, this is what I like to call when TARA, which is a threat analysis and risk assessment, meets the HARA, the hazard and risk assessment, because now it's an integrated risk management. They need to come together. They are not in a parallel or a separate worlds as they have
not
been
in silos.
before.
Oh my God.
Yeah, exactly. So we need to work with it, as you mentioned, Florian. So I was not aware of this previous attack, but I have heard some GPS spoofing attack. So if the GPS, you are trying to provide a fake or spoof the signals of the GPS itself, you will just allocate the vehicle in a different way that might be inaccurate for or that might harm the safety of the driver or the vehicle owner himself. So we need them, we need to authenticate the GPS in order to ensure that the safety requirements are met and the vehicle driver at the end is safe. So
yeah, I mean, in general, so I always say there's no safety without security, period. This is a factual statement today. As soon as your car becomes vulnerable to a security threat, safety is at risk.
I think the industry is also looking forward into fusing the safety and security into a single addressable problem in the future for the software-defined vehicles as well. And if you see the security impact, the first priority is for the safety, SFOP, safety, financial, operational, and privacy. So safety has the more probability and more importance with respect to security as well. So that's why industry is more looking into the fusion of the safety and security into one single process or one single risk methodology to secure the future vehicles.
So I'm seeing the FARA then soon, the threat hazard analysis and risk assessment.
I mean, for safety, for example, in Europe at least, there is a standard ISO 26262. I don't know if this is valid in all over the world, but especially in Europe, it's very popular. If something similar also for cybersecurity there in automotive, or connected? I mean, should it be connected actually in future? That you,
well, they complement each other. So as the guys mentioned, security is now a safety enabler. Actually, the ISO 21434 was initiated. We can say the start point for it was the ISO 26262.
And you can read that. When you read that standard, you feel it is like, oh, that's the brother.
Yeah, exactly. It's just some sort of a derivative of the ISO 26262. The same process, the same methodology, with some adjustment of course, to meet the cybersecurity. But yes, they are both together. You need right now to have both intact in order to make sure that the vehicle is secure and safe.
Yeah, and it's 21448 goes on there too, where you have SOTIF. So those three, Fatih, should always be handled as one like safety security thing.
Okay.
And are actually, so it's not should be, they are. Everybody I'm working with, they use the whole all three of them. And then Karti, actually, you mentioned R155 because R155 is mandating cybersecurity in European Union. But it doesn't explicitly call out 21434, but I have not seen anybody not using it to achieve 155.
No, a couple of OEMs are already got their cybersecurity management systems. So without the certification, they cannot sell their vehicles in the at least in the 57 countries of what is UNEC countries, I can say. And similarly, we have Chinese standards, GB standards, and India it's coming AS 189. It's supposed to release in 2027. I mean, the regulation enforcement should be in 2027. I think they are going to extend to 2029. If you don't have certification, you cannot sell the vehicles. So it's a mandate by the law.
I mean, there is some kind of assessment of that. I mean, that the OEMs has to before SOP certificate. Okay, but what is certified there? What exactly is certified?
So it's called a CSMS, the Cybersecurity Management System. And yeah, maybe you guys are so deep in it. Maybe you can give us an idea what a CSMS actually is and looks like.
Yeah, the experts came up with the standard, which is called ISO 21434, road vehicle cybersecurity. And upon that standard, European Union has this R155 regulation and China has GB standards. So whoever making the vehicle needs to obey this regulation and prepare the documentation. They need to show to the authorities that they produce the vehicle or they manufacture the vehicle with the in a secured manner. They need to demonstrate that. So that's all. If you don't have this demonstration or the documentation, you're not going to sell the vehicles in these regions.
Okay.
Thanks to Brian to post a link in the chat. So for everybody who is interested in looking into that standard.
I mean, this is, so to say, more the theoretical part, of cybersecurity. I mean, we have standards, we have to follow things and so on. But how this can be, I mean, in automotive, we have a certain manner of developing software. I mean, ASPICE is usually used as a process from SW1 to 6, and you have certain steps you have to follow and so on. But how cybersecurity could be inbuilt, so to say, that we have at the end, on the system level, have something which is really secure. I mean, is there anything what can be done? I mean, like in the safety case. I mean, for safety, there are certain measures you have to implement in your software development process that you can ensure at the end your software is somehow safety certified or something like that. Yeah, I mean, but for cybersecurity, I'm not sure. Is there anything like that in place?
Yes, there is, but there's also ASPICE for cybersecurity. Just letting that.
Oh, really? Okay. Okay. I didn't know that. Okay.
Right.
And this can be how this can be enforced actually in the software development journey.
So as Karti mentioned, the CSMS, it's not something that is a standalone per project. It's more about an organizational thing. So your company needs to be cybersecurity certified. So you need to have the cybersecurity culture. You need to have to train your people. You need to include your starting from your IT IT guys needs to be involved. So it's not only related to the software development for the in-vehicle software, but rather than every part or everyone in the organization needs to be abiding to this. And as you mentioned, in the functional safety, we have the safety case. In cybersecurity, we have also cybersecurity case. We have the cybersecurity analysis and threat analysis and risk assessment, so that we are identifying what might be causing the attack surface, where the attackers might be starting their attacks, what is the vulnerable parts. And as Florian mentioned, this is part of the ASPICE as well. So in the ASPICE, it's not only so you have part extending the ASPICE to comply with the ISO 26262, which is a functional safety, and you have also some part extending so that you can include your cybersecurity measures. You need to take that into consideration while you are making your requirements, your architecture and design, your testing, and that's mainly the main focus or the hard work for me from the software point of view, at least, is the testing. So when you need to have a high level of cybersecurity or a secure design, you need to increase your testing. You need to put yourself or put the hat of the hacker, how he would attack you. So this is the fast testing and the negative scenarios. You need to do a lot of things in order to ensure that your product is at least secure from the vulnerabilities that is known at the moment. Because every day, every time with the rise of the AI, like they are being very, very innovative in hacking the cars and finding a new ways. So you need to just not to forbid it or to just disable it at all. You need just to reduce the impact, to contain it, because it will happen anyways.
Okay. But I mean, nowadays with the connected cars, we have not only the software on the car, which is, the car is connected, but we have also backend services, a lot of cloud services running in the cloud. Is this also affected by, I'm not sure if, for example, a cloud service is hacked, would this have any impact on the car? Or
Of course, if your car is more secured and if your backend is unsecured, then the whole company is doomed. I can say that. So if your backend, vehicle, infrastructure, everything needs to be more safe and secured. And CSMS is not only just the standard; it's entered into the every aspect, every department, like quality, ISMS, functional safety, OT security. It enters into the every department of your company. So that's why OEMs or any other company who is developing a product needs to have or create an awareness that cybersecurity is their superpower. If not, forget about the company within 5 to 10 years. Because sorry, Florian, please.
No. Please finish your thought and then I go.
Yeah, if any, always prevention is better than cure, right? So you need to create an awareness in the company that you need to treat cybersecurity as the top priority.
Yeah, and one thing that every software developer or every automotive engineer now has to understand is like this topic is not going to be the same tomorrow or the day after tomorrow. So safety, you can do your calculations and you put in your algorithms and your mitigations and stuff like this. For cybersecurity, as Mabruk said, the attackers are getting very inventive and they are using the forefront of AI cutting edge tools. So whatever is secure today doesn't change until tomorrow, but it might not be secure tomorrow. So this is something that really has to be there. And what I said earlier in this talk is the attackers usually find their way of the lowest resistance. And the lowest resistance point might not be the embedded software in the car. It might be, you hack the phone and you go through Bluetooth. Might be your own phone, super easy to hack. I mean, you root that thing and you can do whatever you want, right? And you can actually go through Bluetooth. So that's bringing you to things like authentication and, like check of reality. However, there's for sure some fancy terms what you do from cybersecurity point of view to not fall for spoofed stuff.
Yeah.
Yeah, and as I mentioned, it's not only for the in-vehicle or what is related to the vehicle. So just imagine you secured your EV vehicle as 100%. You are sure that, okay, no hacker is going to hack anything. You secured the cloud, you secured the auto updates, everything is secured, but you forgot very critical thing, which is the charging station. If the charging stations, for example, is not secured, you are really making a huge vulnerability in the vehicle, because just plugging the charging cable into your vehicle, you have like a new attack surface for the hacker, so he has access to everything in your vehicle. So you need also to consider that. That's why I mentioned it is the full supply chain. It is the full process. Anything related to the vehicle.
Also the infrastructure, so to say. I mean, the infrastructure, everything. Okay. But what about I mean, nowadays everywhere is AI. You have it everywhere on your PC and your smartphone, in your car, everywhere. And I think, what is the role of AI in this context? For example, very well known things are prompt injections. Something like that. Is it also relevant for this in vehicle voice assistance systems and so on?
Yeah.
Maybe I can answer this one because I have been involved in one of the, let's say, case studies for one of our customers, that we need to ensure that the data, or the, like, what we call adversarial attacks for the AI. So we are trying to do, this is a reality that is today, with the AI assistants, they are just doing the automation to have the reply attacks, multiple reply attacks on the vehicle, on the cloud, on the supply chain, that you need to protect yourself against the vulnerability discovery, the social engineering. So they can, for social engineering, previously the hacker is coming to approach you, have like months or even years just to break into your trusted circle. But nowadays, just one AI bot can do the job on behalf of the hacker. So they are utilizing that a lot. And what actually have been done right now, that how can we protect ourselves or our AI or the in-vehicle AI used? Because, for example, nowadays the AI is used in the in-vehicle software, in the ADAS systems, and the perception algorithms and ML models inside the vehicle, and just the hacker can fool the data that the sensors or the cameras are preserving, just putting some sticker on a sign on the road. This sticker is not seen by the human, for example. So instead of seeing, okay, this is a stop sign or a school area, for example, you see, okay, this is a speed range 80 miles per hour. So this is a kind of spoofing or hacking that the hackers might do. So,
and if I may, that can be unintentional. I think I mentioned that before once. So we're in the summer vacation, we were right on the Austrian-Italian border, and we were going over the border all the time. And when you go into Austria, you have a big sign that says this is the speed limit in the city, this speed limit outside the city, speed limit on the freeway. And my rental car read the bottom one, which was 130 kilometers per hour, and automatically put the ADAS system to 130, even though I was driving between two villages. So this is actually an involuntary environmental hack that the car did not detect. So it can happen consciously or unconsciously. That's what I'm saying.
So so this is a great example that this is actually have been done unintentionally. Imagine when hackers just intentionally trying to do that. So
so it's funny that most people think a hacker is wearing a black hoodie and is like hacking stuff in the keyboard, and in the end is pressing enter, right? That's not really how it works in the real world. So there's a vast variety of things. I'd like to take a quick turn here because I think a lot of people dial in because they want to hear what's up with this quantum computing, what's up with the future of cybersecurity. Before we go there, I want to look back. So on the way into this call, I asked my wife, "Is like, what would you ask them?" And she's like, "How about the legacy stuff? Because we have so many products out there which are built already out on the streets, and they were not secured with the CSMS, and they were not retrofitted, but they're actually they are connected. My e-call is out there for years, right? So they are connected. Is there anything happening around legacy that actually, protects the cars which were built between 2015 and 24, let's say?"
I believe this is something that no trend that has been, or no standard that has been followed by most of the OEMs, because this is the transition from a process compliance part, which is the legacy ECUs, to an architecture maturity that you need to ensure everything is future proof, let's say. It's uneven across different programs within the same OEM even. So it's very hard at this time to determine that the standard way or the preferred way that the OEMs is doing. Because I believe the most thing that they are trying to do right now is post the quantum, as you mentioned, for the future vehicles. So targeting 23 and 2035, when the quantum computers will be at hand, as per the recent studies. So I believe this is something that is now of interest for the all OEMs. But again, it's not just okay. Yeah, we have the compliance on the process, but we need to future-proof our architecture and our design in order to like avoid any vulnerability in the future.
Yeah, and I think this question from Brian, by the way, Brian, was great seeing you at CES. The question from Brian here fits right into that. Maybe Karthi, you want to take this one?
Yeah, I can say at least quantum security is not for the future. It needs to be implemented or designed right now. From tomorrow onwards, the OEMs needs to consider this post quantum cryptography or quantum safe security, because whatever they are building today have the lifespan of next 15 to 20 years. So if quantum computer comes available to the public within 2 to 3 years, let's say, the cyber attacks or the quantum attacks are inevitable. So that's why the OEMs needs to consider the quantum security in the design principles from today itself. I can say that.
So
And
since we have a few viewers always who are in their early stages of their career, they might not even understand anything you just said. So can you give like a quick explanation for the newcomers? What's with the quantum computer cryptography and quantum security?
it's a little bit hard right now. The cryptography stuff like RSA, ECC, and other are inevitable, and they can easily hack when the quantum computer comes. So NIST has given some standards, referred some cryptography algorithms like Shor's algorithm can break this. So they have given instructions, or not methodology, I can say the instructions how to implement this post quantum cryptography into the infrastructure itself.
So basically the point is that quantum computers, when they become available, are so extremely more capable that everything we know today, like a password or whatever, is just like hacked in milliseconds. Is that basically?
Like hackers now are already using this stuff, like they call it as a harvest now decrypt later methodology. So whatever you think today that is encrypted, when the quantum computer comes, it will available in the plain English. So that's why they need to have the post quantum cryptography or quantum safe security in their design principles from today itself.
Yeah, because for RSA or ECC that is widely used in the cryptography nowadays, it takes years and years, maybe hundreds, thousands of years to resolve one of the math-based problems. Because at the end, this is hard math problems that needs to be resolved. So using the most powerful computer nowadays that is available at hand with any guy, so it will take years, hundreds of years, thousands of years to resolve one of these RSA or ECC encryptions. But with a quantum computer, this is just a matter of minutes, hours, maybe.
Yeah.
So that what would take a hacker 1,000 years, it will be just less than 1 hour, and he will crack the cryptography. And as Karthi mentioned, that is not for the upcoming 5 to 10 years, for example, because if happens within the upcoming 5 years, like we will all be vulnerable to the cybersecurity breaches.
Yeah. Okay. Given that the cars that come out in 5 years are in development right now, so that's for sure. So the big question, you two, is then, what can we do against that?
So you need to have crypto agility. You need to ensure that in your design, instead of using the default RSA or ECC, for example, you need to use some post-quantum cryptography algorithms that is actually have been available at the moment. One of them is called Dilithium, Kuiper. These are the most popular algorithms that have been used, and actually I have seen some microcontrollers and microprocessor suppliers or manufacturer has been involving some cryptography hardware accelerators in their hardware security modules. So
Oh,
the
okay.
hardware itself is being evolved and in like to support the post-quantum cryptography. So it requires more and complex like CPU capabilities, memory capabilities, because it's longer, it has a larger keys, larger signatures. So the microcontrollers suppliers themselves have a dedicated hardware to support this crypto agility.
So is it like what I have with my password was originally 6 digits and now they ask 8, then 10, then 12? Is that just like a race that you make it more complicated to crack? Or is at one point there also some sort of silver bullet that you say, no, we are doing something more dynamic and we are changing, codes or exchanging? At one point when the seed and key stuff came up and it replaced the traditional just like generic passwords or identification. So at one point, instead of just making it more and more complicated to figure it out, is there actually a way to take a turn somewhere and come up with a different idea of security?
Karthi, do you have an answer? Because this is something in the future, I believe.
Right now, the who are developing the hardware needs to keep in mind that crypto agility plays an important role. They need to develop hardware with respect to this and to secure the current and as well as the let's say legacy systems, the crypto agility and the algorithm changes in a timely manner. It is the best option right now, I can say, as of now. And quantum computer, it will come into the public hands, but quantum computer breaks the trust of what we have building right now today as a digital trust. It will for sure break it. So
But
that's why
I mean, we look on the algorithm parts now a lot, but can we do also something in the EE architecture to make it more secure? I mean,
Secure by
the
design.
vehicle, exactly, secure by design. Can we do something there that the whole system has not a big attack surface, so to say? I mean, to minimize the surface a little bit. What has to be changed in the EE architecture?
right now everyone is moving from domain to the journal. At least a couple of OEMs, I can say, they are preferring the journal architecture. So as you said, secure by design. Right now, from today onwards, they need to think how they can implement this cyber security from the design phase itself or the requirements phase itself.
Yeah, I mean, one thing, sorry, just a real quick thing. So what we did at Tesla, for example, by design, we made sure that there's not every controller has access to connectivity, right? A lot of startups, there's like, oh no, we just like every controller gets their own OTA and so on. And Tesla's like, no, we have one secured controller that gets all the OTAs and it distributes them. So I only have to secure one gate and not 50.
You have, so to say, over one gateway. I mean, this gateway is
Literally
secure. Okay. Okay.
Literally the gateway.
So has been what I like to call is moving from the perimeter security. You don't need to just secure the perimeter of the ECU to just put the firewall at the edges of each consumer of the connectivity, as Florian mentioned. So one approach is to have only one connectivity enabled ECU that is fully secured. You have multiple layers of firewalls just to avoid anything. That because this is enabling the concept of the zero trust. Because if you have zero trust in your all the connected zonal architecture, so you have the bricks now connected to the central computer with the infotainment side. If you treat each one of them as vulnerable or it's already compromised during the architecture bring up, you are trying to minimize the blast radius when the hacker is compromise one of these zones, for example. So just when you're designing, it's already compromised. It has an issue. We need to secure our zone with it. It's not similar to the functional safety from the past. From the functional safety, okay, you have a deterministic flow. What will be the failure? How we can treat it? How we can like react according to it? Because at the end, it was some sort of deterministic failures that we can anticipate and we can react to.
And
But
calculate, right? So that
yeah,
you have probability and everything.
but from cybersecurity point of view, you never know what the hacker will do once he enters your perimeter.
Okay.
That's
I mean,
why I
yeah,
can
go ahead,
say that's why I can say until now we are in a static defense mode, but from now onwards, at least the industry needs to sit in a continuous cyber resilience.
Okay.
So they say in English, they say the hindsight is 2020, which means like later you turn around and you see everything clear, right? And I love this comment from Nikolai on the right side. I don't know if you guys saw it, that his brother's car was stolen because the chief reset. Yeah. The thief, the thief reset the entire software of the car through the unprotected infotainment system. So now, from today's point of view back, and we don't know what year and make and model that car was, but you look back and say that was a bad design, right? So now I think you guys are in the shoes that you have to think yourself into 2030, 35, and it's like, what would I look back and it looks stupid what I'm doing today? Pardon my words here, but what looks so stupid that I should absolutely change that in order to not be that easy to be vulnerable?
You need to have the defense in depth approach in your software design into your in-vehicle software. So you need to employ and deploy the intrusion detection and prevention systems, like something dynamic that is working the whole time. It will be updatable. You need to have the deep packet inspections to ensure that every packets or everything that you receive from your server, from your clouds, are already authenticated. It's meant for you, for your own ECU, and not meant for anyone else. We need to have some sort of a traffic filtering. We need to ensure that we have, as I mentioned, a multi-level firewalls across different ECUs. And of course, with the auto updates, we don't need to just delay the auto updates, because delaying the auto updates when it's pushed from the OEMs, just similar to leaving your door, your car vehicle, your car door open in a bad area of the city. So, okay, you are saying to the thief, okay, please have it and goodbye. So we just need to secure that. This is from the consumer point of view, to be updating or accepting or doing the auto updates frequently. This is matters because we are trying to reduce the attack surface or attack segments a lot. We need to have the faster threat detection and response. And as I mentioned, we need to reduce the blast radius. If one zone is vulnerable, then it needs to be contained here. We need to react here. So infotainment, so reflecting on Nikolai's example here, if the infotainment is hacked, then we need the infotainment to be isolated on the overall vehicle. So the hacker won't be able to get into the central ECU to get the engine running and so on. So this is what we are trying, or what we mean by secure by design, securing your architecture in order to avoid such things.
But you had a very good point, and actually Andrew's comment plays right into this. You also have to continuously detect and monitor, detect and report and act, right? And this is something that a lot of car makers still have to get used to. I cannot put a solution in place that will detect that and then it's done. So if I detect something that I haven't considered before, then I actually have to feed that back into some sort of system, and I have to, develop something to prevent this kind for the next time and stuff like this. So there's this like do, act, check kind of like DevOps loop that you really can't avoid now anymore because it's not optional.
I mean, if we see today's software development, more and more open source comes into the car software. I mean, we have a lot of libraries used, and so on. And these open source projects are available for everybody. And does open source make vehicles more unsecure, or is it? What is your take on that? I mean, because open source cannot be avoided anymore. I mean, it's everywhere, like AI, and open source means the source is available for everybody, also for hackers, for good, for bad hackers, and so on. They can look into the code, try to find some, security holes. What do you think? I mean, is this another attack surface?
Yeah, of course, OSS is a new attack surface, I can say. OSS brings a lot of speed into the software development, or at least into the development of new features. But it also brings a lot of supply chain issues and supply chain risks. So that's why the OEMs, or the who are integrating the OSS into their infrastructure, they need to scan the all the code before integrating into their infrastructure, and continuously monitor the OSS. That's why like back in the days, we have in IT, we have cyber threat intelligence for the IT systems. Right now we also need the OEMs and suppliers also need the cyber threat intelligence, where it will monitor the entire code or entire infrastructure continuously, and give them the at least alerts. What is the code, what is the change, what is the version number they are using. At least this CTA platforms needs to be more evolved in this software defined mobility, I can say. There is a good need of CTI in the future, I can say, from the OSS perspective.
So the important thing is here that the car makers will also close the loop. I mean, I had a post that went viral a couple of weeks ago because a lot of people actually did everything we were talking about. So they did their job for analyzing, detecting, monitoring, solving, and so on. But if the loop is not closing and the fix doesn't reach the vehicle of the customer, none of this matters, right? And especially when you have cyber attacks, you cannot talk in months. You have to basically start talking in hours if you have like the big one coming, right? And in that case, the loop has to be oiled, primed, and ready to go, and not the first time that a fleet-wide OTA is sent out is when we have the fire of hell is bursting, right?
Okay.
And adding to what you have mentioned, Guy, that right now we are introducing the fact or the point of software bill of materials. Previously, we heard of like the hardware bill of materials, but nowadays we are getting towards the software bill of materials. We need to know the standardization for this. It's not a static thing that this is at one time and you are not going to update it. This is a dynamically updated list that we need to trace back to every bit of our software, who has contributed, what, where it's implemented, where it's integrated, how it's used. Because nowadays a lot of organizations are trying to standardize, for example, the cybersecurity layering implementation. For example, Eclipse SDV group, they're trying to do that. So this is in order to make everything available for everyone to share the cost, because having the cost burden or the financial part, this is something huge on the OEM himself to do this cybersecurity part. So this needs to be considered, needs to be handled carefully, because at the end, it's something that, as you mentioned, Fatah, it's already available at hand, similar as AI. So instead of doing the effort, I can just download it, use it, and integrate it.
But is it, I mean, for example, if you use thousands of libraries, in your ECUs, infotainment, ADAS, whatever, and there are databases in the internet where you can see the latest, greatest CVEs found, and there are found some CVEs in some libraries. Is it actually realistic to think that the OEM is able to update immediately this? And I mean, because we have so many issues in automotive, I'm not really sure if this is so easy to OEMs to react fast on that. I mean, I'm not really sure
first
if
of
this...
all, I think it's important that you don't use open source software from the head or from whatever you call it, master or trunk. So where everybody is contributing. Especially when you go into a car where you have safety relevant functionality, you have to fork out and you have to clean that and you have to make sure you have the right parts. And this is where actually a lot of AI tools are being developed. As a matter of fact, we're looking into developing one as well right now, where you can actually I wouldn't say certify, but analyze open source into
Scan
detail.
for vulnerabilities, maybe.
Yes, exactly. So stuff that was before almost impossible because you have 1,000 contributors. But now we have the ability using AI tools, or we will have soon, to almost like put a seal of trust on open source code, or not, and then you can't use it or fix it.
I mean, there is one. I mean, I remember just one thing. I think it was in a Debian distribution. Some people try to contribute to the XZ library, I think utils library, to compromise SSH at the end. I mean, it was a long process, you know.
Yeah.
They and at the end, it didn't came to the main line of Debian. It was found before, but I can imagine that such silent attacks can happen also in certain libraries which are very much used in automotive, you know.
And that does not urgently have to be on purpose. So we had this a long time ago at Tesla. We had this scenario in testing that we found out that if you play a proprietary Nintendo tune over USB, it actually opens a port that you can use for a cyber attack.
Oh,
but
really?
It was
Okay.
because it didn't go out to the customer. We
Okay.
found it before. But first of all, it's like, how do you come up with that? Second of all, how did you test that you find that? I don't know either. But what we found, and I wasn't part of that group, I just heard about it, but what they found is that it wasn't really part of automotive software. It actually, over time, it trickled through and ended up in some piece of open source that ran in our audio system.
Yes, we need to have a standardized process, or each OEM or each supplier, they need to have like a checklist, a process on how you are handling your open source libraries from safety point of view, from security point of view. Use your tools to do the scans for vulnerabilities.
Okay.
Use your tools to ensure that from functionality point of view, like, is it memory safe, for example? Is it going to be fit into our key features and not affecting it? So we need, like, we can't just ignore the fact that we have an open source. This is reducing the cost dramatically, so we cannot ignore it. We just need to handle it in a smart way.
Yeah. Open source is not for free. I mean, this is very difficult to understand for many people, especially in automotive, you know. I mean, I had this discussion very often.
Download it.
Exactly. Open source is not for free. I mean, you know, this is but people have to understand this. This is very difficult.
Actually, the computer I'm looking at runs Ubuntu, which is, I can download it for free, but I actually have to dedicate quite some hours of my monthly work hours to keep everything up and running. And that's just a simplified example. So if you use open source, you have to understand that you have to maintain, you have to analyze, you have to understand. But I also want to say that, like, professional open source software is not the Wild West, right? So there's a lot of change management going on. There's a lot of configuration management going on. But of course, you gotta at one point clean it up in order to use it in a commercial project or product.
Florian, recently we had a discussion on the rise of cyber attacks in the automotive. Have you also considered this open source for this rise that you mentioned? Around 6,000 attack vectors were mentioned.
So that wasn't my number. I just quoted a guy who was giving a talk, but he explained, and yes, for sure, it's the complexity of the system. It is also the different contributors to the system. And let's not assume that somebody actively tried to do that. Obviously, that's a risk as well, but there's also like the involuntary like threats you bring into this. So it was 6,000, the number 6,000 times the threats, not attacks. So he's like, he did a calculation that because of all the different angles of attack compared to an EE architecture, you have like 6,000 times more angles or more threat opportunity. That doesn't mean that they all exploited. And for sure, open source plays into that, but the same as the complexity of the system, as well as the connectivity that we all cherish and want. Because I wanted to add something on what Mabruk said earlier, is we have to do all this like securing and extra firewalls and so on. But one thing we must not forget, for the customers, we cannot slow down anything we are doing, right? So you cannot secure everything and then say like, oh, but your car will have like 1980s behavior when you change the volume or something like this. So everything has to be as fast as it is plus the added cybersecurity on top?
There is an interesting question actually.
Vishwa
Open
mentioned
source.
open source scan is already a checklist point in many companies. How will a new process might help?
I mean, is there any regulation actually from the process point of view how to deal with OSS? I mean, in automotive, I don't think so, right? I
I
mean,
guess there is a standard, not a regulation. Uh, Companies who are using the free and open source software needs to pass this standard. I forgot the standard name and number, but couple of companies are already having this standard in place. They need to develop internal policies, how they are using it, how they are collecting information from their suppliers, what the open source or pre-open source software they are using in their libraries.
okay,
All they need to get the information.
Yes.
Okay.
I
But
mean,
I
that's
forgot
part
the
of the cybersecurity assessment for suppliers as well, that you have to list up all this kind of stuff. But I think there's two different things, right? One is the what are you using, and the other one is how well do you understand
Yeah.
what you're using? How well did you actually look into that? And that's getting challenging. I mean, no kidding, right? But it is going to happen. So you can't, as an OEM, you can't lock the door and say, I will not join the OSS, the open source software train, and I just like ignore it and I will build everything myself. This is not going to be efficient, neither financially, nor from productivity point of view.
Okay.
But it doesn't, just an add-on, it doesn't have to be open source to everybody. You can also have shared open source projects where you are working on with a larger group, but it doesn't mean that you can just like, go on Git and contribute a malicious file to it.
Yeah. But yeah.
You never know
Right.
what will happen in the future, because previously, like maybe 5 or 6 years ago, you never know that we would not imagine that there will be a specific standard on how you can like have a safety in your AI and ML models that you use in vehicles. Because nowadays we have the ISO pass 8800 that is standardized for how you are going to treat your AI, the trained data that you are feeding to your ML models inside the vehicle. So this is some sort of a standard that has been like introduced to the world due to the fact that this is a fact that we use AI and the algorithms that we for the ADAS systems specifically. But in the future, when the rise of the open source will be happening, I believe we should see some sort of a standard that is going to regulate or have this checklist standardized across all the customers or all the OEMs.
This is also my expectation actually. I mean, because at the moment it's a wild west somehow regarding OSS. Everybody's using something, especially with Linux. Linux became very popular in the recent years in automotive. Everybody wants to use Linux somehow, but Linux is not was not designed for automotive or for safety or things. But now it becomes very popular. And I think we need some kind of a regulation how we deal with such things. I mean,
so does anyone know? And that's a question actually to everybody who is watching as well as who is in the room. If anybody knows somebody who is working on something like this, please put it somewhere in the comment or let us know. Shoot us a direct message. And then Fatih, obviously the interest is high on this whole topic, so we should definitely find some folks from the open source community and get them here for one of the next talks and see what they are thinking about. Not only for CS point of view, just in general, open source is a very, very interesting topic.
I mean, there's one question here from Adam.
How about
So the IDP, or the intrusion detection and prevention system that we need to deploy inside the ECUs that we are having at the moment or the future ECUs, just to be, as I mentioned, like agile or cybersecurity agile, because we need to detect the intrusion, how the attacker or the hacker is going to breach our system, how it's going to do that. We need to ensure that the intrusion detection system will listen to the vehicle communication. It's sniffing all the paths that can be detecting what's happening, to have the monitoring for that in order to have the detection of the failure. it's kind of, we need to have like the detection methodology itself. Maybe we can have some signature based, some rule based, some filtering. Maybe we can in the future even have some AI based to have some to monitor the behavior of the bus. Okay, we know that the bus in the normal scenario will be working as this way, so this AI model will detect, okay, if there is an expected behavior in the bus activities that might lead to, okay, there is an issue here, we need to monitor that, we need to identify that, and then we need to report and response, reporting to the, for example, to the car owner or the driver. Okay, we have an issue, we have vulnerability, please check that. Maybe he can just submit a report for the engineering team through the cloud, for example, to do a remote diagnosis. Maybe he can go to the garage. So I believe the intrusion detection systems nowadays, which is a traditional thing that we use into our web browsing, for example, it can be easily implemented, and actually it's already implemented into the vehicles nowadays.
I think what Adam had in mind was probably something like when you go on a website that doesn't have an HTTPS and you get a warning, and he's like, are you sure you want to do that, right? So something like that, the system's like, oh, I might not accept that because it is, and I might reduce function because I cannot be sure, something like that. Then you go into your DevOps loop.
Okay. I mean, is there anything from, I mean, Karti, you told that you used to work for DECRA, right? I mean, is there anything from these institutions actually there for some kind of a certification or something mandatory at the moment? Or, I mean, some checks from
the
these TÜV or DECRA or something like that?
To be frank, I didn't get the question first of all.
I mean, actually, sorry, let me answer first. Yes, and second, the question is what kind of mandatory certification can actually help for the cybersecurity. So in Europe, you have to have that.
Is it cybersecurity or OSS? Because I thought that he might be talking about OSS.
Sorry. Yeah, okay, I might read the question wrong too.
Yeah, because yes,
okay. I also understand this in the cybersecurity context, but Mabruk, you're right. Probably it's for OSS. I don't know.
Yeah, because for cybersecurity, yes, we have the UN regulations 155 that is nowadays it's in place that, okay, you cannot sell the vehicle without being cybersecurity compliant.
Yeah.
This is something that we have nowadays. For OSS, I believe we don't have. I'm not sure, to be honest.
Okay.
But it's definitely an option, and this is actually something we at Process are working on. How can you actually get a quality report on open source software?
Okay. I mean, you're scanning and providing some report, or
correct.
This is exactly what we do nowadays. So we are scanning the software in order to detect any open source code that has been used. If there is any is being used, we need to trace it back to the source, check the licensing, check that it's not vulnerable, to do the scans and so on. Because you cannot control all your developers when you are an OEM. You have multiple suppliers, multiple tier 1s, tier 2s, and so on. So you need to do the scan. You need to provide this OSS compliance, or that your software, for example, is free from open source software. Back in the days, we were providing this, doing a scan. If there is a single function, for example, has been reused from from previous Stack Overflow, for example, or something like that, it needs to be justified. Where is the repo? Is it licensed? Is it secure? Is it safe? Is it okay to be used? And so on. So I believe this is still in place, and maybe in the future, or maybe as any of the audience know, someone is working on a standardized OSS checklist, for example, to be very helpful. Yeah.
I mean, I have a small question. Who in this ecosystem, who is liability if anything happens on the free and
this
open
is
source?
exactly
this is the question.
This is exactly the question at the end. Who is liable for that?
That's the financially, technicality wise. Every OSS will have support from the community for next 3 to 5 years. Then after that, that's the main question.
Exactly.
So basically, I think at one point, as I mentioned that earlier, you have to, as an OEM or whoever is using it, you have to fork out and you have to take over responsibility for it. So that is, from my point of view, because cars have a lifetime of 17 years, give or take. and UNECE demands 15 years after end of production for cybersecurity updates. So we're talking about long term, right? And it is definitely something you have to keep into consideration, because if you take software OSS now and you put it in, you have to own that for 25 years.
Exactly.
At the
Yeah,
end of-
I mean, thanks for this. I mean, the time is up. Actually, probably final words from your side. I mean, the time. I don't know when this 1 hour just passed. It's a very interesting topic. I would like to continue, but our time is over. Do you want to just mention some final words? If yes, feel free. Otherwise,
Yeah, from my side, for the audience or for myself, continuously aware that cybersecurity is the superpower that you need to build within in your DNA, either to make your life more safe and secure, reliable, or the work environment where you are working. So keep in mind, keep in consideration that your superpower is the cybersecurity. So that's
Thanks.
the I can say to the audience, or at least to myself, that I need to be always aware.
Thanks.
Yeah, maybe I can say that nowadays we can distinguish between a vehicle and a computer, because now the vehicles are turning into computers or some software on wheels, with this maybe hundreds of millions of lines of code. That is massive responsibility to be accountable for one person or one entity that should be accountable for this. So cybersecurity, previously it was only an IT issue. Now it's functional safety issue that we need all to take care of it. We need to ensure that it's inside our DNA, as Karti mentioned, that it's inside our architecture, from the very small sensors that we are using to the massive HPCs that is doing the full computation, and the supply chains. And the OEMs, I believe, shouldn't applied to the hackers, because this nowadays we have the ransomware attacks, and they are asking the OEMs to pay for the ransom and so on. So we need to be as resilient as much to this cyber attack. So we need to raise the awareness about the cyber security and its main rule, and to avoid any adversarial attacks that might happen in the future.
Okay.
Yeah,
Florian,
and
do you have
it's not.
some?
Yeah, it's not optional. If you build cars, you have to put a lot of understanding and effort into cybersecurity. There's no way you can just let that pass. You have to be capable, as Karji said. You have to build that superpower, else you will have a major problem.
Let's close the session with a very disruptive idea from Andrew. Actually, OSS OEMs. I mean, I think this is not so easy. Open sourcing OEMs. I think, but it's a nice idea.
Let's see.
Why not?
That might be a great,
Why
great
not?
project,
Thanks.
an open source car. Let's do that one.
Yeah, why not? Why not?
Maybe
Thanks
an
for
RC
joining.
one.
Yeah, thanks for joining. Actually, I mean, we are
All right.
already over with the time, and see you next time in the next episode. Thanks.
Bye.
Thank you, everyone. Thank you.